There are two concentric circular copper wires with radius 1 cm and 20 cm. They are placed with the same axis and the centers coinciding. The first part is to find mutual inductance of the arrangement. Second part, the magnitude of the induced EMF in the inner loop if the current passed through the outer loop is changed at the rate of 5 ampere per millisecond. Assume magnetic field of inner loop to be uniform. There are two concentric circular copper wires, radius 1 cm and 20 cm. They are placed with same axis with centers coinciding. So the outer loop 20 cm, radius capital R. Inner loop 1 cm, radius small r. They are placed with the same axis and same center. Means they are coplanar and concentric. Now to find the mutual inductance, assume a current I1 is passed through the outer coil, taking the outer coil as 1 and inner coil as 2. When the current is passed through the outer coil produces a magnetic field. The inner coil is very small, 1 cm. So we can assume the magnetic field to be uniform, constant across the cross section of the inner one. That is what given in the bracket also. Assume the magnetic field on the inner loop to be uniform. So because of this magnetic flux, the second coil will have the magnetic field produced by the first one, coil 1, will produce a magnetic flux in the coil 2. So the magnetic flux linked with the second coil, phi 2, is proportional to current passing through the first coil, because the magnetic field produced by the first coil only producing flux in the second one. Second coil don't have its own current, so no magnetic field of its own, no flux of its own. The second coil will have a magnetic flux only due to the magnetic field produced by the first coil. It means phi 2 flux in coil 2 is proportional to current in coil 1. Then the proportionality constant can be removed, called mutual inductance M. So phi 2 is equal to Mi1. The mutual inductance, what we are asked to find, M equal to phi 2 by I. Now the expression for magnetic flux is BAN cos theta. Since flux is linked with the coil 2, it will be BAN cos theta. Only thing, the B is coming from coil 1, because coil 2 don't have its own magnetic field. The area, number of turns, all will be second coil. The B also, that was the second coil, but since B is 0 for the second coil, its magnetic field is same as what produced by the first coil across its area of cross section. So phi 2 will be B1 A2 N2 cos theta by I1. Now N2, it's only one turn, two concentric circular coils. So coil 2 is 1, coil 1 also 1, so N2 is 1. Cos theta. Theta is the angle between area vector and magnetic field. The magnetic field produced by this coil is out of the screen. The area vector is perpendicular and out of the screen. So both are parallel, theta is 0. So cos 0 is 1. It becomes just B1 A2. We substitute here B1 A2 by I1. Now B1 for a circular coil is mu0 I by 2R. In this particular case, mu0 I1 by 2 capital R. A2 area of the inner coil pi small r square by I1. B1 is mu0 I1 by 2R. A2 is pi r square by I1. I1 get cancelled. You get mu0 pi small r square by 2 capital R. That's the expression for mutual inductance of the two coils. Now we can substitute the values R and R, small r and capital R. So mu0 is 4 pi into 10 to the minus 7. Pi small r is 1 centimeter, means 10 to the minus 2 meter. Square is 10 to the minus 4. 2 and 2 centimeter, 20 centimeter will be 2 into 10 raised to minus 1. 20 into 10 raised to minus 2, 2 into 10 raised to minus 1. This 2 to 4 get cancelled. Pi and pi becomes a pi square. Pi square can be approximately taken as 10. So 4 will go 10 raised to minus 1 as it is. 10 raised to minus 4 becomes 10 raised to minus 3 because pi square is 10. Then this 10 raised to minus 1. So 10 raised to minus 1 and 10 raised to minus 2, 10 raised to minus 2. So total 10 raised to minus 7 plus minus 2, 10 raised to minus 9. So the mutual inductance is 10 raised to minus 9 Henry. Now for the induced EMF, Faraday's law, induced EMF in coil 2 is equal to d phi by dt of coil 2. E2 is equal to d by dt of phi 2. Phi 2 is equal to m times of I1. Since m is constant, m can come out of the differentiation. So E2 equal to m times of di1 by dt. M is already calculated as 10 raised to minus 9 Henry. di1 by dt, they given current in the outer loop. di1 by dt is 5 ampere per millisecond. So 10 raised to minus 9 into 5 ampere by 10 raised to minus 3 seconds. 1 millisecond is 10 raised to minus 3 seconds. So minus 3 minus 9 will go minus 6. So 5 into 10 to the power of minus 6 volt. That's the expression for, that's a value for induced EMF, and that's a value for mutual inductance.